All right, I've been continuing to work on the idea of using standard PVC fittings to turn an ambu PEEP valve, an ambu bag PEEP valve, into an inline PEEP valve. And previous attempts look like this or like this, quite bulky and honestly not something that seems like it's ready for prime time. But after some additional discussions online with the group today, I had some additional thoughts. First of all, somebody brought up the idea of using clear tubing, which is a great idea. I don't have any clear tubing, nor was it readily available. So with clear tubing, you could do something like this. If you could imagine, I'm going to go ahead and switch it out. If this was clear, you could imagine doing something like this with the PEEP valve in here. And that would allow you to be able to see what's happening down as the bolt interacts with the plunger. However, if you want to do that, that's fine as well. However, I think there's even a perhaps better design. It still remains opaque, but it becomes so small that I really like the way that it looks. So again, we're going to use a standard 1.5 inch threaded to 1.5 inch slip coupler, which our PEEP valve is going to, which we've unscrewed the top from. PEEP valve is going to fits in quite nicely. And we'll just seal that. And instead, what we're going to do, we're going to use a cap. It's a 1.5 inch slip cap. We're going to put these together. We're going to join it with a little bit of 1.5 inch pipe. And then we're going to drill a hole down the top, which will allow us to activate the plunger. And once this is together, we will use a hole saw, 7/8 hole saw, to put a hole right in the side here. And this is where a 15mm port will go. And that is such a better design. Also looks like something out of a video game, but such a better design. So I think this is going to be fantastic. And you should be able to line up the bolt through that small hole, particularly if you use a clear 15mm connector. Okay, so let's go ahead and start with a cutting off 2 inches of 1.5 inch pipe. It's gonna have to be real precise. And then we'll come back to it. All right, so 2 inches was maybe a touch too long, so 1 3/4 inches looks like it's gonna be okay. And that's gonna help mate these two together really well. So 1 3/4 inch piece of PVC. One 3/4 inch and 1.5 PVC pipe. How confusing is that? So now I just want to get these ready to be joined together. PVC is naturally mated by epoxy, but when you roughen up the surface, should be no problem at all. There's that. Same thing, other side, a little bit of steel wool. You can also just use sandpaper, it's fine. A little bit of alcohol, get the wax off. All right. Now we're ready to start the first joint. Some epoxy. I'm gonna mix a lot, and you'll see why. This is 2-part 5-minute epoxy. The reason I'm going to mix a little bit more is because the cap isn't as thick as some of the other fittings, and so I'm going to let some pool in the bottom, which should give the threads of the bolt that's going to be adjusting the PEEP valve a little bit more to bite onto. Don't need much here. I'm just going to put these two together, push them in, and then you always turn it. All right, good. That's going to be well mated. Now I'm going to take this other bit and then just kind of let it fall into the bottom here. That is going to pool there and form a nice reinforcement to the top of the cap where the bolt is going to go through. All right, so we're going to go ahead and let that set, and then we'll come back and finish it. All right, so the epoxy has set and has now formed a little pool in the bottom here. It's been about 3 hours, and I'm going to go ahead and now drill the hole in the side for this 15mm adapter to fit into. Now, in order to get a nice clean hole, I'm going to use a 7/8 hole saw. This is going to give a really nice clean hole. You could use a drill bit, but I don't think you're going to get a very clean hole out of a spade drill like this. So you can certainly do it, but expect to do a little bit more sanding and filling if you use something like this. So going through a soft material like this, I'm going to start in the forward direction, and then I'm actually going to try to go backwards and use the back side of the teeth here to finish the cut. So I'm going to aim to go right by the edge there. See how this goes. If I lose a hand. There we go. So that should fit perfectly. Very nice clean hole. Jeez, almost hard to get out. So that is just about perfect. Just what I was looking for. So next thing is going to be to drill a hole through the top. I don't have to be super precise, but I'll try to get the center point there, drill a hole through. I'm going to use a drill press for that, although again you could do it by hand because the distance is quite short to the top of the valve. Now you can see just peeking through there. Oh, this is going to be great. Be back in a sec. All right, so I'm just finishing up sanding off the letters from the top of this cap, just to make sure that I can get a nice clean surface to mate to. Again, I'm not anticipating that I'll really need this second seal, but if I'm going to go through the trouble of putting it in there, I might as well make it a good seal. So I'm going to clean out these two holes here. So I used a 7/32 drill bit for this hole, and I anticipate that this is going to be very tight. In my experience, putting a hex bolt through this size is very tight, and because I want to be able to manipulate this bolt by hand, I'm going to have to probably drill this out again after I put the bolt through once, just to remove a little bit more material. This is a 1/4" hex bolt. I wouldn't actually recommend this bolt. It's just all I could find. A 1/4" eye bolt would be much better, but unfortunately I couldn't find the right size. It would look something like this. This is a 3/16. It's a little too small, but that's what I would want the end of this to look like, so I could manipulate it easily with my hand. You could always 3D print a knob for this, but not really all that critical. So what I'm going to do is start by putting on my nut. This is going to be my locking nut. Put down my, that looks too big, put down my standard washer, and then my rubber washer. So that's what's going to seat against the top and create an extra seal. Now, the other thing I'm going to do is put a little bit of Vaseline on the threads. I mean, this is like almost nothing. Just a little bit on the threads. That'll help them. I'm not going to put it down by the bottom where I'll be trying to cut in, but just there should be good. Okay, and I need to go find my socket wrench. All right, got my socket wrench now. So what I'm going to do is just allow the bolt to cut the threads here. You certainly could use a die and tap, but I really like the idea of smushing the material, or compressing the material out towards the side and then allowing the threads to sort of find their own path. I think that's what's going to give us a really good seal. So you want to be somewhat careful about keeping the bolt perpendicular while you're doing this. It's actually going in really easily. So obviously I would want a much shorter bolt, but this is what I had handy. So try to give you dimensions on the actual bolt that you would need. So now this will slide together. You can see that bolt is headed right on the correct trajectory to hit that. Not quite turnable by hand. I'm hoping that once we play with it a little bit, it'll be able to be turned by hand. But look at it, right on the nose, hit it. So all set there. Okay, all right. That is fully compressed. Just kind of working the threads back and forth a little bit to try to make it a little easier to work with here. This would be turnable if I had an eye bolt, so I'm just going to leave it like this. It's almost hand turnable, so I'm just going to leave it here. All right. So I'm pretty happy with the positioning. Everything seems to be lining up appropriately. So I think I can go ahead and do the final assembly. If I had a little bit of misalignment there, I could always just rotate this assembly until the bolt was lined up well. But as it is, I'm doing pretty well, so I'm going to leave it where it was. Okay, cool. So I gotta degrease my hands real quick. Mix a lot of epoxy this time. Again, this is 5-minute, 2-part epoxy. First thing, given the Vaseline, just put a little alcohol on the paper and just wipe the inside here. Again, kind of decreasing this, also decreasing this. I'm also not confident that I'm also not confident that I roughen this surface, so I'm gonna go ahead and do this again. Just a little isopropyl alcohol. All right, let's do our final joining here. Didn't have to get too crazy with the pressures we're dealing with here. As long as it doesn't fall apart, that's pretty much all you need to worry about. Put these together. I'm gonna set my valve back in temporarily just to make sure things are pointed appropriately. Turn it. This kind of spreads the adhesive around the joint. That's pretty good there. That's looking really good. Put that there. Pop this guy out. Now, I'm gonna stick this guy down. Inside of that is pretty rough, but I do need to roughen this side up. This is a standard 15mm connector you get from our respiratory therapy setup respiratory therapist. Let's see here. Any other examples? There's another one, slightly different color. And then here's another one, Caesar. Any one of these will work. They're all fine. Roughen this surface up. Just a little bit. Again, get the grease off. Bit of rubbing alcohol. Same thing here. All right, now I want to be careful not to slog too much of this on the, to drip down inside here to get on the valve. So I'm going to put it, I'm going to favor it towards the outside of the joint here. Keep it more towards just really light coating on the inside, just to fill in any crevices that are in that. Put these together, push, do a little turn. You can see I've got good push out all the way around. Still plenty of clearance in there. Turn this one more time. I can barely do now. Clean up some of the excess. Now I can see the valve. So make sure it's still headed in roughly the right direction. Alright, it's looking good. Again, I'm going to use hot glue here as I only have a couple PEEP valves, so if I have to rescue this PEEP valve from this setup, I want to be able to. So, all right, this is it completed. Again, looks like a video game character to me, but bulletproof. I really am satisfied with this. So again, normally you'd be able to turn the valve if you had some sort of connector here, but it's a little bit difficult. So that's with some PEEP. Just crank this down a slight amount. Quite a bit more. So it's definitely functional. And then once you get your PEEP set appropriately based on your monitor, just go ahead and crank this outer nut down, which will improve the seal, which I don't think is an issue, and then also keep it from migrating on its own, which again I don't think is an issue. So I think limitations of this design still is perhaps a tiny bit on the heavier side, but other than that, not being able to see the valve is a bit of a limitation. There is, in theory, if you were to over crank down on this bolt, you could, although there is a mechanical stop, if you can turn this by hand, you can feel when you've reached the end of its travel and you've reached the support structure for the valve. You could over tighten it and break the valve. Again, flow should always be in this direction. There's filters in places. I don't appreciate anything that would crack off and become free floating, but it is at least good to be aware of and make sure that somebody with experience is moving this valve. As we talked about, if you wanted to see the valve itself while you were moving it, you could add a clear section here. I didn't have any access to any clear tubing, but you could, instead of using an 1.5" joiner in the center, you could use a 4" or 3" section of clear tubing, which would give you an inch window into the inner workings, and that would allow you to see what's going on and how far you're depressing the valve. The other option is the valve itself will almost fit in the end of 1.5" tubing, So it will sit down against this rim. So the rim of the valve will sit down against the rim of this piece of tubing. I wasn't really happy with that. I didn't really feel comfortable that I could get a good enough adhesion that it wouldn't break off, which would create an open circuit. But here with this lip, you get a good mechanical, not only adhesive, but you get a good mechanical blockade as well. So very happy with how this turned out. I think it's going to be a nice option for people. Again, this isn't something that you're going to see rolled out in New York, I think, but you know, for people that are in resource limited environments, or if there ends up being a short on the parts that we need, this is something that you could definitely mass produce pretty quickly in a more limited environment. So, all right, thank you very much.